We're one variable because we're only going to be asking about one piece of information. In tomorrow's lesson, you're going to learn about what happens when I ask you about two pieces of information and how do those graphs and information look like. So what a frequency, when I say a bar graph, it could be referring to a frequency bar graph or a relative frequency bar graph. Remember, frequency is just the counts, where relative frequencies are the percentages. Now, something important to note is that these two graphs are technically going to be identical, except for the fact that the percentages, the y-axis in terms of how you label it, will be different. And then we have a pie graph. Now, some notes here about these. Bar graphs are for categorical. A lot of students will mix up bar graphs with histograms. When we get into the next chapter, we're going to talk about histograms. They're different. Bar graphs are for categorical variables. Histograms, which we haven't even learned yet, are for quantitative. But what's also important here is that there are no space, or so, sorry, not no, it's the spacing are intentional, purposeful. They're there for a purpose. We do not use 3D, and we have to make sure that they are evenly spaced. So all of the bars should be relatively the same space. So you don't have really skinny bars and really fat bars. As you learned in your reading last night, this has a very bad effect in terms of how people interpret graphs. If you use three-dimensionals, or if you have some graphs or parts that are very small and others that are very big, even though one value might be just a little bit more than another, it'll look like it's much, much, much larger than that is. So when you're drawing a bar graph, and if I ask you to draw a bar graph, to the best of your ability, the spacing between each bar should be the same. The best to your ability, they should be evenly spaced apart. So the spaces between the bars should be evenly spaced, and the bar spacing themselves should be about the same. So when you draw a bar graph, you have, like, it looks like your basic X and Y. The who will likely go on top, or likely it does, and the what goes on the bottom. So yesterday we talked about what? Vision, and we had 22 students yesterday. I don't have the data right in front of me. How many students did we have yesterday?
22.
22 AP stat students. So now comes the next question. For my bar graph, how tall? I'm gonna make it right here like this. How tall does my y-axis need to be for the data that we had yesterday? Now, what is the, first off, there's two separate questions. What is the maximum my y-axis needs to be to? And secondly, for the data that we collected yesterday, how high does it need to be to? Sorry, let me also repeat these. This is labeled as, we also label this as the frequency, the counts. Okay, so this is the frequency. So how high does the frequency need to go to?
Just to go up to 22, I think.
Well, it doesn't. So there's a little bit slight in terms of your wording. At most, it can go up to 22. Okay, at most, it needs to go up to 22 because there's 22 students. However, we're going to have multiple bars. So we're going to have a bar for glasses. We're going to have a bar for contacts. And we're going to have a bar for neither. Okay? So, which one had the most responses? The glasses. And how many was that? 11. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So all I have to go up to is 11. All right. Now notice my y-axis spacing as well in terms of marking is as evenly spaced out as possible. Now, how many had glasses? You said 11. Was it that's the answer? 11 had glasses?
Yes.
So my bar will go to 11. And just for posterity reasons, to make sure, I'm going to write 11 just to make sure I can see that that's 11. How many people had contacts? Ooh, 1. Ooh, my bar is a little bit too high already, so I actually drew my bar a little bit too high. So right around there, and there, and there was just 1. I'm going to write it with black. It doesn't matter. And how many had neither?
9.
Well, that's only 21 students. So was it 12 students had classes then?
I think so.
Oh, okay. So I have to go to 12. That means I have to go just a little bit higher. Right there. There was 12, 1, and 9. Now that makes sense. And so 9 goes around right here. And now you've just made a bar graph for our one variable categorical data. It's as easy as that. Vision is the title of the variable. 22 AP Stat students. Remember, all answers pretty much always have to have who and what. Did I say my who? Yes, 22 AP Stat students. Did I say my what? Yes, vision. Did I describe the distribution in my graph? Yes. It tells me that there were 12 students with glasses, 1 student that wore contacts, 9 students that had neither. My spacing is relatively to the best of my ability, about the same. So notice the spacing between here and here is pretty much the same. And the bars are relatively the same spacing. And my markings between each of these little pieces, relatively as good as possible, are relatively spaced out the same. Notice also that I wrote the frequency of my title. You need a title both your your y-axis. So vision and frequency. So that's how I do a that's how I do a frequency bar graph. But how do I do a relative frequency bar graph? Now notice what I'm going to do here. Okay, watch this. I'm going to now draw a relative frequency bar graph. And I want you to note that everything stays the same except this. I did this purposely. The only thing that changes will be the y-axis. It's a carbon copy. And literally, I copied it. I copied and pasted. I had technology, so I was able to copy and paste. But the graph of a relative frequency histogram and the graph of a frequency histogram, or bar graph, are identical, except for how you label the y-axis. What did we get for 12? What was the percentage for glasses? What was the percentage that we got for glasses from yesterday? Somebody real quick. 54.5%, I think that was. My memory serves me correctly. So
54.5.
So if I went by like 5%, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, and 55. I mean, it's about the same right there. I mean, technically I would have erased those markings and I would have made the markings a little bit better, but basically it's all the same. And these are I want to put these are in percentages. So it's 5%, 10%, 15%. And then the bottom one down here was, I believe, 4.5%. And this one was 41%. And most of the times, I'm never going to ask you to do both. I'm not going to ask you to make a bar graph and a relative. I'm not going to ask you to make a frequency and a relative frequency. I won't ask you to do both. I wanted to do this for a purpose here that it has it. But if you look over here, it looks right. It's actually I drew those a little bit off, and basically they follow the same. Yeah. Yes.
I have a question for the homework. Said the homework said lecture note and lecture video. I noticed what we're reading for chapter 3.
I don't understand what your question was.
So for the homework, it's a lecture note and lecture video.
Those aren't homework. Those aren't homeworks. Those are what I do from class. I'll post the lecture notes, but there was no lecture video yesterday that I had to be able to post because the recording didn't work. I'll answer those questions afterwards because I want to get everybody off and going. Let me just finish my lesson real quick on terms of that.
Okay.
So finally, the last thing I just wanted to point out in a pie graph, pie graphs are appropriate when the percentages are clearly different, and of course we have categorical data. In other words, what do I mean by this? So you don't want to use a pie graph. First off, if you're not dealing with categorical data, you're not dealing with percentages. You need to have categorical data and percentages for pie graphs. Pie graphs are also important that they are clearly different percentages. So for example, this one right here seems to be pretty good. 41%, 54.5%, and 4.5% are pretty much relatively different from each other so that I can actually utilize them for actually cutting off in terms of the slices. So, you know, a pie graph looks like here, and so this one might look something like, you know, like that. That's the, this would be glasses. This would be contacts right in there, and then neither. That would be a 54.5%, 4.5%, 41%. That's how you would do a pie graph. But the question that also often gets on which one is appropriate to be able to use. Your homework, I want you to, I had assigned this kind of yesterday and I had changed it. Homework number 2. The homework comes from chapter 3. Remember, chapter 3 exercises. That means you go to the textbook. You can locate the textbook in the link on Google Classroom. From key information. You can locate the link from the textbook in the weekly organizer at the top of every page. You would go to part 1 and then chapter 3 exercises, problems 6, 10, 12, 16, and I'm going to put a little star on question 20, which means I'm not going to grade it, but I want you to attempt it. Question 20 actually will preview a little bit of what we're going to do in tomorrow. If you did the reading, I want you to attempt it. I will answer those questions a little bit better, but it's based on today's topics really. 20 is going to be a little bit outside your comfort zone. 6, 10, 12, 16 should be relatively straightforward and easy to do. You have the rest of class to take care of your